In the section M.2.3, we're going to explain the relationship between two variables. We've already seen a little bit about this when we were doing the graphing sections in section 2.1 and 2.2. You've actually seen them on a graph, and you saw how some of the ways that they're described. The first paragraph in this section here says, variables allow us to work with quantities that are both known and unknown from the past, present, and future. A variable represents a quantity that can truly vary. Much of your work will involve the relationship of two variables and how the change in one causes a change in the other. Being able to mathematically describe or interpret these dynamic relationships between these two quantities or two variables is essential for your success on the TEAS task. So as we've done in the past, we're going to look at our objectives first to make sure we understand those. We're going to describe how changes in one quantity affect changes to another quantity. You've seen a little bit of this when you did the graphing in section 2.1. We're going to demonstrate knowledge that a variable represents a set of potential values. You saw this in section 2.2. This is the new stuff, the stuff we haven't talked about before. We're going to identify positive and negative covariance. We're going to identify dependent and independent variables. So now we're going to look at our key terms. Covariance is the way two variables change together. Either both variables are going to increase together, as one increases, the other increases, or they're both going to decrease, as one decreases, the other decreases, or one can increase while the other decreases. This is the three different types of covariance you could have. You also could have dependent variables and independent variables. The definition for a dependent variable will be a variable that depends on at least one other variable. An independent variable is a variable that determines the value of another variable. An example would be if you were looking at your paycheck and you were trying to figure out the paycheck amount. Your paycheck amount would depend on the hours you worked or your hourly pay. So in this example, your paycheck amount will be the dependent variable. It depends on either your hours worked or your hourly pay. The independent variable will be the hours worked or the hourly pay because they determine what your paycheck amount is going to be. So that's an example of independent variables and dependent variables. And as you can see as you read through the rest of this section here, that when you sit down to study for a class, you increase your knowledge and decrease your free time. When you buy a latte, your caffeine consumption goes up and the money in your pocket goes down. So as one increases, the other decreases. Here's another example. I only listen to the radio when I drive my car. And when I drive, I always listen to the radio. As the mileage on my car increases, my radio listening time also increases. So you can kind of see sometimes this makes a lot of sense as far as what the relationships are mathematically, and sometimes just more along the line of how you listen to things. Now that we've talked a little bit about dependent and independent variables, let's go back and talk about covariance. It says we describe this relationship between variables as covariance. If both variables increase, a positive covariance exists, and the variables are directly related, so as one affects the other. If one increases and the other decreases, there is a negative covariance, and the variables are inversely related. So remember these definitions here of positive covariance, directly related, negative covariance, and the variables are inversely related. As we look down here at this example, we can read in the paragraphs, it says, in all of these problems, one variable depends on another variable. When the first quantity changes, the second quantity changes in response. The increase in the odometer reading causes a decrease in your fuel tank reading. So the more you drive, the less gas you're going to have. This is what this is saying. The first quantity is called the independent variable, the odometer reading. And the second quantity is called the dependent variable. That will be the gas in your tank. And you can see that you could use the x-axis is usually the horizontal axis, and that would be the independent variable. And the y value, or the y-axis, or the vertical axis, will be the dependent variable. That's the way you would normally drive or create a graph. As we can see from this example here, it says, as the price of a barrel of oil increases on the world market, the Dow Jones Industrial Average usually decreases. The price of a barrel of oil is the dependent variable because that determines whether the Dow Jones goes down or not. And the Dow Jones is the dependent variable. This is an example of negative covariance because as one goes up, the other goes down, and they're inversely related. Here are a couple other examples where we can see what the covariants are and whether they're directly related or have independent variables, dependent variables. As the price of a barrel of oil X increases, the price of gasoline Y at the pump increases also. So both the price of the barrel of oil and the price of the gasoline increase. So if we graphing that, we'd have a graph that's going up. And so they're directly related and have a positive covariance. Also, another example would be as the price of gasoline G increases, then the number of miles we travel decreases because higher gas prices is going to lead to less travel. So as one increases, the other decreases. This you would have a graph going down if you had drawn it. So they are inversely related and have a negative covariance. So you can see how two different variables can be related positively or negatively as far as covariance, whether they're inversely related or directly related. Just have to think about it. If they both go up, then they're going to be directly related and have a positive covariance. If the graph is going down, then as one increases, the other's going to have to decrease, so they're inversely related and have a negative covariance. This is something that might be easy to tell from most graphs if they're kind of in a straight line, but if they have one of those that are curved, then you might not be able to tell. You would have to have it on a short area. Which part do you want to talk about? So as you're going through this section, just kind of look at your graphs or look at the information they give you and kind of decide, are they directly related? Is one a dependent and one an independent? And how are they related as far as the covariance? Good luck on this section.